Well, I don't really know where to start with this video, but I'm going to start with what went right and what went wrong about this Vladimir Bulatov's stellated dodecahedron shape. It went right because it worked, and it's all symmetrical and everything's the right shape and size. It's the same size as my other stellated dodecahedron, which is useful. And what went wrong, well, not wrong, but if you look at the Vladimir Bulatov one, it's got a lot more space where these overlap each other, and I was trying to figure out how I could have done that. I couldn't do that the way I did it, because what I did, I sort of picked this shape based around a 10 by 40 blank, like that, out of the original kite, and I needed those points to act as reference points on my German ring. But the Bulatov one obviously comes outside of the constraints of that 10mm, so he probably went up to, like, I don't know what size he was actually, but if it was on proportion to mine, it'd be like 14mm, and that came way off centre, so the centre line being there, and the pass-through area is this little area inside here where these things have to pass each other in those corners. Let's see if I can get that close up. See where they pass by each other? There. There. So if you stretch it out, pull that right outside of the tips that I used as the centre by another 2mm, which would make this a 14mm by 40mm blank. Now you can't use the German ring the way I've done it to do this. There is a workaround you could come up with. I suppose you could mark these points off for 10, turn it for 14, and then expand these curves out. That's a possibility. Anyway, that was just an observation more than a going wrong. It was how it differs from the Vladimir Bulatov one. Right, and then generally about the direction that I'm going, I started off with turning spheres, as you know, lots of spheres, and then into these platonic solids like the dodecahedron and the icosahedron and cubes and all of the platonic solids, and some others like this, I think that's an Archimedean solid, a rhombic dodecahedron. Then I figured out how to stellate them, so to put, and what stellation is, it's simple enough. It's if you extend all these faces out, they come to a point. So inside that is one of these smaller, and you can see that in this latest one because I've put little, well, you can't see it in this light really very well, I put little gems on the faces of the insides of these where these pentagrams cross, and there's a little dodecahedron inside there, and like this the points come out following these. So that's more progression over the last 2 years. Has gone from spheres to the platonic solids to stellations of the platonic solids and Catalan solids and Archimedean solids. You can look all these things up, and this is something that I think it's a shame people stop learning about shapes when they're about 3 years old, and they stick with that collection of shapes that they've learned, And it always reminds me of the square, what's it, square slot meme, the girl with the square slot. Where does the circle go? It goes in the square slot. Everything goes in the square slot. It's a funny meme if you haven't seen it. I think it's an act, but the point is that people's cognitive dissonance gets a little bit broken when they start thinking beyond the shapes that they were when they were 3, which is a shame to not keep learning about shapes. Anyway, that's an aside really, because my next port of call with this is to try and get a little bit creative, and I haven't seen this shape, is to stellate a cube. If you stellate a cube truly, if I can get this in shot, the stellations themselves are like rectangular, cubic rectangulars, because you're projecting out these faces at the angle that they naturally fall, so it's parallel to each other. And what I want to do is create one with like star points. So I'll start with a cube in the centre, and then bring them to points. Now this isn't truly a stellated cube, and my next project is going to be turning this as a solid like this. Just so I've got one that I can use as a visual aid. But that's not a stellated cube in fact, because if we take those tiles up, they'll form little peaks, little square peaks above the surface of the cube, and that is in fact a stellated deltoidal icosahedron, which is a word I'd never heard of till I started to try and find out what this was this morning. Because that's the good thing, it's something else that you're learning all the time, and there's lots of other ways that you can stellate these things. I think that's what it is, but I'm not certain, because I saw one with the points coming out the corners as well, which would be an interesting turning, but no, not now, because it's easy to get ideas, it's not easy to go through with them. So I'm going to stick to my guns with this. I'm going to make that first as a solid, and once I've got that, I can do this kind of form of it. Oh, by the way, the finishing on this took forever. I mean, I just kept going and kept going and kept going with finer and finer. Kept putting teak oil on, then knocking it back and putting more on and knocking it back until the teak looked like teak, and antique, you know, like antique teak. And that's how I wanted it to look, and that's how it looks. But it took absolutely hours just finishing it once it was this shape by getting little Q-tips with little bits of foam back to abrasive and working inside. And I also put a good healthy drop, about 2/3 up, of epoxy resin into each of the tips to give it some reinforcement, because those CA glue joints, if you dropped it with CA glue joints, they're more or less likely to break, because it's a strong joint, apart from it can snap under shock. So that's giving it some degree of reinforcement. And in fact, those little glass, you can't see them, there's little glass there, you can see one in there, gems I've put on each of the inner faces inside there to bring out the dodecahedron, and that'll give it a little bit more strength around those central joints. So anyway, back to that. I'm going to turn that first as a solid, and then as one of these, whatever they're called, forms, like a pasty looking form, but it's not, is it? Whatever it is. And then I'm going to turn well, I'm going to make a cube, but it's going to be surprising how I'm going to make that cube, because it's just not. Oh, sorry, going back to that a second. I'm going to turn that shape, starting with this sphere, which I marked up ages ago. I can't even remember why I made this. I made it for something, but I can't remember. Anyway, I'll turn this into that. So start off with a sphere. Now I've lost my track again. Oh yeah, the cube. I'm going to make a cube, 80mm square cube, 80mm cube, which the faces go back into sphere, into what would be a sphere in the centre, and then this shape is going to come out of holes in that sphere, and that takes a little bit of creativity, because the creativity is in the process, it's not in the final result really. That's going back to Reese Turned in Oz. There is creativity in these things, it's just maybe not like that. There is creativity, and the creativity is in the process, you know, how you get there. It's not the end result, that's not creative, because somebody else has made that first. So you could say I'm not being creative, but it's how I did it and the tools I used to make it. Anyway, so that's where I started, spheres. Then I went to platonic solids, then to stellating platonic solids, and then to doing these, which is a more complex form of a stellated platonic solid. But there are also the Catalan solids and the Archimedean solids, and all in all there's only 20 odd of them, 26 I think, I'm not certain off the top of my head, to learn. And then to learn the stellations, and there's like rhombic, tricontric, you've got to learn the names, there's no other way to do it, and it's not difficult. As I say, why stop with your learning at the age of 3? Carry on, learn as much as you can, and it allows you, it gives you the flexibility to make better things. Right, another thing is, this is just another step in the progression, because the next step that I want to take is making these with the knowledge of those structures, is to make organic forms. So things that look like corals, and you know, organic things. You learn a lot about organic forms making these, by the way, because of all the ratios and the shapes that do occur in nature, in plants, in crystals, in all sorts of places you find these structures. So yeah, my journey is continuing with trying to make these as organic forms, like in the art of well, Vladimir Bulatov does some organic ones, Bathsheba Grossman makes organic forms, but all based on these kind of mathematical structures. And it's not really complicated maths, it's O-level maximum, I would say. It's just the visualisation gets hard. Anyway, that's enough of a ranty debate discussion, I don't know. Thanks for watching.